In this module, I'm going to introduce the notion of functions, a few special examples of functions, different types of functions, and so on. Because this module is a little bit longer and will span over multiple PowerPoint files, I want to sort of keep a structure of this uh, overall presentation over here. First, I'm going to define what a function is, what it isn't. I'm going to introduce the notion of a subset of a domain. So we are going to introduce the notion of sum and product of functions. Then I will define specific types of functions, namely one-to-one functions, and a category of this called strictly increasing or strictly decreasing functions. I will define onto functions. The notion of bijection is based on combining one-to-one function and onto functions. We'll talk about that. I will talk briefly about graph of a function. This is something useful to figure out, for example, how does the function look if I plot it, and we can use that plot to get some idea about what the function is doing. I will introduce the notion of an inverse function. Inverse functions only exist if the function is a bijection. I will define the notion of composition of functions, and I will introduce some more specific functions that are important in the number theory world. They include floor, ceiling, factorial, etc. Before we define a function, let's look at a particular example. Let's consider your final grade in CSE 260. Your grade will be from one of these sets. So it's either 4, 3, 5, 3, 2, 5, etc. So let's try to see what are the properties of this set. And also let's think about what are properties of this mapping. I will have about a 30-second pause here. Try to write as many properties of these mappings that you could think of, and then I will discuss what are some of the specific properties that I'm interested in. Okay, so here are some of the properties that I'm interested in, and these properties will be important when we define what a function is. First question I want to know is, can one person have two grades? The second question is, can a person have no grade? Answer to both these questions is false, and in other words, every person is going to have exactly one grade that they are going to get, and that is basically the key characteristic in defining what a function is. So let A and B be two sets. A function f from set A to B. We generally write this as f colon. That means f is the name of the function. Then we are going to put a colon after that. A arrow B. So this is a function from set A to set B. It's an assignment where each element in A is assigned exactly one element in B. So in our previous slide, A would have been the the students in the class and B would be one of the grades, then each person must be assigned exactly one element in set B. We write this as F colon A arrow B. We can also write this as F of A is equal to B. So if I take an element A in set A, we write F of A is equal to B if B is the element assigned to element A. One thing I want to emphasize is this notation looks very similar to the implication sign, but this has nothing to do with the implication sign. This is just mathematics using the same notations for different things. We also say F maps A to B, and formally we can write this as for all x in A, there exists a unique y in B such that f of x is equal to y. Note that how to convert this unique existential to just existential is something we have talked before, and I would ask you to review this as well as to how we can convert this exists unique to just standard exists and for all operator. Here is an example of a function from A to B. Here we have some students, we have some grades. So in this case, Adams has gotten 1, Murray has gotten 4, Stevens has gotten 3, Sarah has gotten 3 as well. We can write this in terms of a function that looks like this. F of Adams is 1 because Adams is mapped to 1. Let f be a function from set A to B. In this case, A is called the domain of f, B is called the codomain of f. If f of A is equal to B, then we say that B is an image of A and A is the pre-image of B. The range of f is the set of all images of elements of A. That means you can start with set A and see where each element is mapped to. The union of all those elements will be the range of the function f. Let's review the question. How are codomain and range related? What we want is the range is a subset of codomain. Range may be equal to codomain, but it may not be equal to codomain. So let's look at an example. So here image of Murray is 4, image of Stevens is 3, and so on. If I look at pre-image, then pre-image of 3 is Sarah and Stevens, pre-image of 0 is the empty set, and so on. The range of the function are all elements where something is pointing in over here. So it would include 1, 3, and 4. Let f1 and f2 be two functions from set A to set R, which is the set of real numbers. Then we can define functions like f1 plus f2 or f1 times f2. So f1 plus f2 of x is you take f1 of x, you take f2 of x, and then you add them. f1 times f2 of x is you take f1 of x, you take f2 of x, and you multiply them. That will give you f1 times f2 of x. Note that these operators plus and minus make sense only if the domain of f1 and f2 is same. Otherwise, it doesn't make sense. Let f be a function from A to B. Let S be a subset of A. Now we can define image of S is basically start from an element in S and see where the function takes you. That's going to be the image of S. Formally we can define this as take all images f of S where S lowercase s is an element that is in the capital S, which is the set. Note that if I set S is equal to A, that means I take all elements in A, then f of A is basically the same as the range of f. So in previous example we had if I look at the set S as Adams and Sarah, then f of Adams and Sarah would be 3 and 1. Once again, we have reached the check before you go ahead slide. Here, I want you to look at whether the things that I'm going to define are likely to be functions or not. So S is a set of students, C is the set of courses, R is a set of real numbers, and X is a set 1 through 65. Which of these are likely to be functions? From S to R, where we map the student to their height. S to X, again the same thing, we map the student to their height. Let's assume that the height is to the nearest inch. And from S to C, that maps students to the course they have taken. Again, the answers are at the bottom of the slide. If the answers don't match with what you have in mind, then be sure to check with me or the TA.